Hi everyone, here's a video lecture on velocity conversions, which most of you voted for, so here we go. Hope this is helpful. Okay, so first off, what is velocity? Often we'll use velocity and speed to refer to the same quantity. So velocity is a speed with direction. Most of us have probably heard the word speed before. Speed is a distance over a time. Velocity is technically a displacement or change in position over time. So if there's no time interval, like there's zero time that passed, then you can't have a velocity. But if time is passing and something doesn't move, like you're standing in place, your change in position would be 0 meters or 0 feet or 0 inches per second. If you're moving faster or covering more distance in a given amount of time, that would mean your speed and your velocity would increase. Velocity technically should have a direction, so that direction could be right, left, up, down, north, south, east, west. And next semester we'll talk a little bit more specifically about when a velocity could be positive or negative. Sometimes we'll set positive direction to the right, negative direction to the left. So the variable that we'll use for speed as well as velocity in this class is lowercase v. Usually it's italicized. And some possible units you might see to describe a speed or describe a distance or displacement over time would be miles per hour, kilometers per hour, per being the fraction bar, centimeters per second, or inches. Whoopsie, this should be inches per, let's say, inches per minute. Okay. The SI units, the International System of Units in a science and engineering context, would be meters per second. And then the equation you might see for velocity is the change in distance or change in position over a change in time. So if you're only given one distance and one time, then you can just plug in these values. This delta triangle means change. Okay, let's keep moving on. So here's an example of a car race. And we have the black car overtaking the red car, meaning the black car is covering more distance in the same amount of time. So maybe the black car is traveling 110 miles per hour. To the right, notice that I included a direction, so it's technically a velocity and not a speed. And the red car is moving at a velocity of 105 miles per hour. So we have two tasks. We are trying to solve for the velocity of let's try the black car first. We're trying to convert the velocity into feet per second. So in any conversion, if you're given a value and you know it's not the SI unit, you want to stop, drop, and convert and figure out what your goal is. So the goal in this problem for part A is to figure out what units you want to get your value in. So if it's asking for how many feet each car travels in 1 second, our final units will be feet per second. And let's specify that we are doing this first conversion for the black car. Okay, so now we're going to type in our starting value. So for the black car, the velocity is 110 miles. So MI is the abbreviation for miles. And then per hour. So we could put 1 hour, or we could leave out the 1 and just write hours. Either way would work. Okay, and then let's fill in our goal units on the far right, feet per second. And let me move this to the right. Okay, so let's first convert distance. So on the numerator and the denominator of this first fraction, we should have units of distance over another unit of distance. So our goal is to get feet on the numerator. So we want to get rid of miles. So to get rid of miles, instead of multiplying by miles, if I did that, I would get miles times miles, which is miles squared. I don't want that. That would be an area. So I'm trying to divide by miles. So I'm going to write that here. And then I'm going to write in feet. Actually, let's go from miles to meters first. And then I will show how these cancel out. Format, text, strike through, miles, format. Okay, so if I were to stop here and fill in my conversion factors, I'd be left with a certain number and then meters on the numerator per hour. So meters is a smaller unit of distance than a mile, but I'm not quite there yet. So now I want to get rid of meters and I want to convert to feet. And then I'll plug in my conversion factors. So let's show that meters is going to cancel with the meters on the opposite side of the fraction bar by division. Okay, so if I look at the conversion factors that I set up so far, I have, if I were to stop here, I would be left with feet per hour. But I need to get to feet per second. So I need to add one more row, or column, excuse me, on the right of this to convert time. And for my conversion of time, I'll change this to a different color to show that that's separate. So again, I'm trying to convert, right now I have feet on the numerator, so I'm good to go here. And then I have hours on the denominator. So if I want to get rid of hours or cancel out hours, in this case I have to put hours on the numerator. So hours divided by hours should cancel out to 1. And then I'm converting to seconds, which is what I want. There we go. And let's strike through this. And strike through, just showing that these units cancel out, and this is a great way to check if you've set everything up correctly for your fractions. Remember, the vertical line is multiplication, horizontal line is division. So now I'm going to bold this, and it looks like I have my goal fraction set up correctly. Okay, so I have a conversion of distance, distance, time. This is my final answer. So then I fill in the conversion factors. So that if I refer to those in my foldable, there are 1609 meters. I'm going to unstrike through this. In 1 mile. Control-Shift-X. Okay, and then there are 3.3 feet in 1 meter. And then I know there are 3,600 seconds in 1 hour. Okay, so in my calculator I would multiply 110 times 1609 times 3.3 divided by 3,600. You could enter the ones, but it wouldn't really affect your final answer. And you always want to start with the value on the far left side. So if I type this into my calculator, 110 times 1609 times 3.3 divided by 3600 equals, I'm going to round to the 100th place, and I get 162.24 feet in 1 second. So if I were to count to 1 Mississippi, the black car would have traveled 162 feet in 1 second, which is a pretty significant distance. So now, feet per second are not the SI unit. So I am going to next try to get this value in meters per second, which is the SI unit. Okay, so for meters per second, let's just convert the red car's velocity from miles per hour straight to meters per second. So we have a different example. So red car is covering less distance in the same amount of time, and we're trying to get 105 miles per hour into our goal of SI units. So again, velocity is distance over time, so we use the SI unit of distance, which is meters, and the SI unit of time, which is seconds. I would recommend pausing and trying to solve this problem independently before playing the video again and seeing how I approach this problem. So in this case, again, I'm going to convert distance first in the first fraction, and then time in the second fraction. So if I'm getting rid of miles, I need to divide by miles, and I want meters on the numerator. These can cancel. And then I'm good with meters. I can bold this. Bold, we're good. And then I want to get rid of hours. So instead of dividing by hours, that would give me hours squared on the denominator. So I want to multiply by hours. Hours would cancel out. And I want to put seconds on the denominator. And that matches my goal unit. So again, this whole fraction needs to be equal to 1. So if I say that my video lecture lasted 60 seconds, that would be equivalent to 1 minute. So same amount of time on the numerator and denominator, so it should equal 1. So 1609 meters in 1 mile. And then we have in 1 hour, we have 3,600 seconds. Again, you could go from seconds to minutes, minutes to hours if you wanted. So in my calculator now that I have my units all set up correctly, I would type in 105 times 1609 divided by 3,600, and my answer in meters per second would be 46.93 meters per second if we rounded to the 100th place. So if I were to count to 1 Mississippi in 1 second, the red car travels 46.93 meters in that second. Please comment below with any questions, or feel free to email me. Subscribe so that you'll get email updates when I post new videos. Thanks for watching.